Okay, so I think that we should start with the presentation and then we will showcase the actual robot. This is the robotic head that we made. It's a fox, obviously, and the original concept was to make a playful fox that hopefully wouldn't be in the uncanny valley and be too scary. To do this, we have done a couple of design choices. For example, we have used the compliant mechanism to allow a simpler mechanism and smoother motion, and also we had it be a little bit wobbly to make it look less so scary. For the other mechanisms, we have the ears. The ears are very simple, they're just servos with an ear attached on top, and then we have the jaw, which had a servo to open it and close it. The eyes are probably the most complex mechanism. They can move left and right with the mechanism that we were given, and then the eyelids go on top. As you can see in the image, the fox looks a bit different. Of course, doing all of these colors would be very hard, since it would be a very sharp line between the different furs, and we didn't really have such a white fur. For the actual robot, how it's made, we have a base for the head, the skull. It is 3D printed in grey PTG, obviously, and the fur is attached on top with the Bostik glue. At the start, we wanted to use many zip ties on the head because we thought that zip ties were great, but 2 days ago we were told that it would be better to do something of higher quality. And so yesterday we remade the entire head, using as little zip ties as possible. The only zip ties in the head are one zip tie for holding the wires together and two zip ties for holding the accelerometer because we didn't want to scratch it. We also used the zip ties to attach this to the Obsidian because we didn't really have another way.
We redesigned the head with the support of the servo integrated to the head. Also the two external pockets for the support of the neck.
So the head has a quite low part count because all the supports were printed together with the skull. So we basically only had to attach the servos and it was basically done. So here you can see some renders of the skull attached on the compliant mechanism and how it looks like. And here it is mentioned about the compliant mechanisms. So for the materials, we have the PTG skull, we have the fox fur for the fur, and there is the black nose, which is made of TPU because we originally wanted to have like a soft nose, but we didn't really have time to print it, so we only have this black piece of TPU. Okay, so the whole robot is controlled obviously with the Obsidian and OpenDAQ. It can even be used as a standalone, so it does not require the computer to operate. We have integrated some user interface, let's say. So there is the accelerometer and the thermocouple. The accelerometer is in the head so that when you pat the robot on the head, it has a reaction. And we thought that this would be quite interesting. And we also have a thermocouple on the outside to measure the air temperature, ambient temperature, so that it can react if it's too hot. To assemble the robot, some parts couldn't be printed together. So for example, this is the eye mechanism, which we welded with a soldering iron to the skull. We could have printed it together with the skull, but that would be suboptimal, since there would have to be support on top of the part, and this would reduce drastically the print quality. So we did the animations with Bottango. We were able to do the animations quite quickly. Things that we learned were like how to solder. Well, only two of us knew how to solder, and even we became better. We learned about 3D printing. I think only I ever used a 3D printer or used it many times, and I had never printed with a Bamboo Lab, and so also the Bamboo Lab software was an interesting experience. Applying the fur was something that we found to be quite difficult. I mean, not that difficult, but applying the fur on it so it doesn't wrinkle or not having to stretch it was quite hard, and that is also something else we learned. We definitely learned about teamwork. We collaborated very well, I would say. And the last thing here in the list is that we learned how to use CAD better. So most of us became much faster at using it. There are some things that could have been done better. For example, we wanted the neck mechanism to be springy, but it's a bit too springy, I think, and we could have put the fur on the eyelids because they don't look great like this. Conclusion, this is our robotic head. We think that it's made relatively well, though of course it could have been done better if, for example, we started building this robotic head before. Okay, you want to say anything?
Let's go for the animation.
Okay, let's do the
Yeah, we
animation.
can try it. Let's try if it works now.
Something else?
Okay, so it's like hot. Close the eyelids. They were closed before, but because we left it,
Yeah.
it was the last animation running. So now it opened them. Okay, so it's not hot anymore. So another animation we have is it gets scared when we, so accelerometer is in the head. So if we let's do this, it's start to like look around and check for danger in the surroundings. And also one more animation we did is dancing. It was supposed to work, so we like pet it friendly a few times, but we'll see if it works. So yeah, this triggered the scared animation. It was quite hard to get it to work, but it did in previous iterations of the robot. Yeah, okay, no, this is the scared animation. So I guess we broke it in the last iteration of the software.
Yeah, a couple of other things I would like to say is, so as you can see, the Obsidian is split vertical. So we chose this main for a couple of reasons. First, this printed base like this is smaller, it takes less time to print. Also, having it vertical is more comfortable to work with as it's higher up. And something I would like to say for sure is we had to use this connector here for connecting all the wires to the Obsidian, and let's say that the jumper wires have pins that are a bit too short for that connector. So we had many issues with the wires disconnecting. Okay, do we want to show also the too hot animation?
Yeah, I already did. Like, so if I touch this, okay, so it like puts head back and closes the eyelids a bit, indicates like the hotness in there, and goes back to the previous position.
Okay, should we introduce ourselves?
Yeah.
So I was the team lead, and I have never had really any experience with their robots or really even servos. I mean, I once tried and failed to make a servo operate with an Arduino, but that was a long time ago. So this was definitely a new experience, and I think that I learned quite a bit about control and also for the mechanisms.
Hello, I am Klemen. I am more of a software guy. I mainly, with Antonio, did the animations, make the software work, tested all the joints if they move correctly, the servos, and that's about it.
I'm Adam, have a degree in mechanical engineering. The most important thing for me here was probably the teamwork and how we came together to a conclusion, although we are different and have different backgrounds. And then it's also interesting to see different visions to solve a problem. Like, let's make an example. If me and Etto are designing this room and I say, oh, the light should be blue, because it's my favorite color. And then Etto say, no, it actually should be white, because then you'll be able to see. Nice to see how you can solve the problems, although you have different backgrounds.
So hi Matteo, I'm a mechanical engineering. Never worked with this type of projects before. So this is the first time I design and print with Etto and Adam the head and the support for the eyes and the neck. I really enjoy to put the fur, as Mr. Passeri explained to me, because I think it's similar to laminate the carbon fiber. At my university, I'm a member of a team where we built a car made of carbon fiber. So I think it's really similar put the fur because it's really difficult and for the shape of the head.
So I'm Antonio. I'm currently studying aerospace engineering. So in my university, I work in the propulsion department for the rocketry team that we have there. I'm for sure 90% a type 2 engineer, so I love getting my hands dirty. It doesn't matter. It doesn't matter if it's concrete, dirt, grease. I mean, this was far away from my field of, let's say, not expertise, but I'm like used to work with not this type of things. My abilities, like programming and using software, are quite low, and working with OpenDAQ and Obsidian was not quite difficult, but we struggle a lot, like trying to get things working, because sometimes we spend like an hour plugging and unplugging, and things started working when you plug it the fifth time. Or even yesterday, we were like testing things, everything worked, and this morning we came here without changing nothing. We plugged the Obsidian in, and the highlights stopped working, the ear stopped working, so we managed to get some of the servos working. But yeah, definitely, I think that we did a good job, taking into account that we don't know each other. We like had to do this project in 3 days, like other teams have said, doing this in 3 days and without knowing each other, because I'm sure that if we worked with people that we are used to work, maybe it would have been like faster. But the point of this, I think, is that getting working with people that you don't know, so that you can prove yourself if you are really able to manage the situation, because in the future in life, it's not easy. Sometimes you will have to be working with people that you don't know for 2 or 3 days. So yeah, basically that. Thanks for the team, to the staff, because they taught us a lot and they helped us a lot. For example, in our case, Andre was like a key part in our development, because we are having, like I said, a lot of problems with the software. So yeah, thanks a lot to everyone here.
Any questions?
Imagine, like, you just came in this room and you saw a robot like this, and tried to think, like, would you find it something difficult and complex if it was the first time you saw it? So would you like be okay, like, this is just simple, few 3D printed parts, few servos, I could do this like pretty easily? Do you think that would be your reaction or not? And if so, why?
At least on my part, usually I thought that building a robot would be quite hard. But when we actually started designing, I thought, well, this actually seems pretty easy. I mean, after all, we have only 8 servos in total, and most of the mechanisms are very easy. For example, the ears, as I said, it's just the ear screwed onto a servo. So I would say that I think that it was easier than I originally thought, but a bit harder than what I thought at the start of the project, because there were quite a bit of problems that we did not expect. So, for example, there were many problems with software, but even for the mechanical parts, like sometimes the printer would, for some unknown reason, print quite badly, and this would mean that the part we had just printed did not have the right tolerances for example, fitting the servo. And this was quite a problem, because if you want to fit the servo in a bracket, then you need to have very tight tolerances, because if the part is a bit too big, then the servo will be loose. If it's too small, the servo won't fit.
I think that the most important problem is when you try to assemble all things, and so the problem arises.
And test everything together.
Like, if you want, you can each like try to answer that.
Yeah, I mean, so in the middle of the project, it looked like, okay, we're gonna do it, it's gonna be like not such a problem. But then like testing everything, working together and assembling everything took much time, and little problems like occurred on every corner. And in the end, it was quite difficult to get it all working.
Yeah, for me, one of the main problems that we had were like building the robot was mainly like Matteo said, assembling everything together and seeing that everything fits. And also, I think that we work not very parallel to each other, so we needed to wait until the hardware was completely done to test the servos. At the end, we only had this morning to test the full animations on the Obsidian, like the robot built-in. Yeah, like I probably previously said, the testing was like let's say the worst part of the project. But I mean, at the end, we managed to get something done, even if the cables are not that beautiful.
Well, I think the cables are quite good. I think the best we could have done is hiding the cables under a cloth, but this many cables are needed.
Are all the servos working as they were supposed to do it at the beginning, or you had some problems? And also, if you had the chance to go back and start from scratch, can you list two things that you would change in your approach and technical choices?
For the servos, we have, for example, the eyelids don't close as much as we originally intended, but in the end we decided this was kind of fine. Also, the jaw didn't have the same range of mobility. As for what we would have done differently, so for example, the first thing I can say obviously is I think it would have been better to print the mechanisms first and then the skull, because we didn't know how big the mechanisms were. We couldn't print originally the brackets in the skull. We printed the skull immediately because the first day the 3D printers were all offline and the skull was the only thing we had ready. So we decided to print that because it wouldn't take any extra time.
So regarding the question of the servos, we tested all the servos. So all servos work. I mean, they turn, and the problem is that the problem comes in the software. I mean, we don't know why. So the problem actually we cannot fix the problem. All the servos work. The problem is that the animations do not work properly, and for example, the jaw, it doesn't move at all. It's like really wobbly, and the highlights, for any reason that we actually don't know, they are closed. But like I said yesterday, we tested the eyes and the highlights and the ears, and
No, they work.
the highlights work now.
Yes.
Yeah.
Oh, good.
2 hours ago, testing the highlights were completely closed and didn't work. So
Let's say that many things now work that before didn't work. Yeah, that's kind of unexpected. I thought that we would have quite some problems on stage with the wires disconnecting themselves during transport or something. Okay.
So thank you.
Bit
I
harder.
will say committed any thoughts to add?